Fundamentals of Physics by Halliday, Resnik and Walker is a Bible for undergraduate students while teaching motion, which is part of the syllabus of RTM Nagpur University BSc Semester 1 as per NEP. I was dealing with the topic of motion in 2 dimensions, and there I encountered with the 2D rabbit problem from this book. As I have solved it in Maple beyond what is asked, I have prepared a video for you. I am Professor Shyamkant Anwane, associated with Sri Shivaji Education Society, Amravati Science College, Nagpur. So let us begin our discussion. I'll read the problem for you. A rabbit runs across the parking lot on which a set of coordinate axes has been drawn. The coordinates in meters of rabbit's position as a function of time t in seconds are given by the following two equations, and the author is asking two aspects. At t equal to 15 seconds, what is the rabbit's position vector r bar in unit vector notations and in magnitude angle notation? Another aspect is to plot a graph of rabbit's position for the time interval from 0 seconds to 15 seconds. Let us deal with the problem. Solving these parametric equations is not much difficult. Every first year student can do it, but here I have explored Maple for better understanding of this two-dimensional wonderful problem. X of t, the position is parametric function of time by this equation, and the another position, that is y of t, is also parametric function of time, and here you can evaluate the position t equal to 0 and t equal to 15 seconds. So here you can work out approximately x of 15 is equal to 66 and y of 15 is equal to minus 57. So r bar can be written as 66i minus 57j cap, and r will be under root of x square plus y square. So 66 square plus 57 square under root is approximately 87, and theta is equal to tan inverse of y by x. So herein we can calculate theta equal to minus 41 degree. The calculation for all positions up to you can say 25 seconds. So serial number is going from 1 to 26, and the experiment is starting at a point that is t equal to 0. So x of 0 28, y of 0 30, x of 15 is equal to 66 and y of 15 is equal to minus 57. R is 87, and theta, when you calculate, that appears in radians, and that is to be converted into degree later on. So this thing students have to understand very clearly. Here x of t is an independent variable we are considering for plotting in Excel, while y of t as a dependent variable we are plotting on vertical axis, and this is the position of the rabbit at t equal to 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. This is the point of interest we have. Then here we have to draw a vector starting from origin to this point. So here the magnitude of the vector is r that we have calculated, and the angle subtended with x-axis is theta. This is to be understood. Now I would like to explore the features of Maple animation to solve this problem and realize what is happening. Here I have loaded Maple 2022 for this 2D rabbit problem that we are discussing. Statement of the problem, if you like, you can pause and read, and for the solution I have written these many commands. I'm going to execute them one by one, restart will clear all accumulators, and with plots will enable the plot module. Position x is parametric function of time by this equation x of t. Similarly, y of t, I am defining a ball which will track the position xy, and the ball will be with color blue, and symbol size is selected 20. Now we shall animate the position where t rolls from 0 to 25 seconds, you can see. So this is how the rabbit is going to track its position, which is represented by parametric functions x of t and y of t provided to us by Halliday, Resnik and Walker. Now to trace the position, I am using another animation command so that I'll be able to locate the position of the rabbit. Then the next objective is finding theta, which is parametric function of time, and position, that is a radius vector, which is under root of x of t square plus y of t square. So obviously r will be function of time, r will be a parametric function of time. So theta function of time and r function of time we have calculated, and now I want to see the animation, wherein on x-axis we are going to have t that rolls from 0 to 25 seconds, and the second quantity is theta in degree. To obtain that, we have multiplied theta by 360 upon 2 pi, and we are having 25 traces. So here you can see theta t with time. Similarly, we can use Maple to calculate theta t at t equal to 15 seconds, that is converted into degree, and you can find the answer minus 41 degree. Now we can animate r of t on y-axis, time on x-axis, 25 traces as desired for 25 seconds. So you can see r has some maximum value here. Similarly, one can work out x component of velocity. V square bracket x will designate v suffix x, which is d dt of x of t, that is rate of change of x position. And similarly for y, ball with a red color we have chanted, and you can find out Vx, that is x component of velocity, as parametric function of time. These are like equations of line, a pair of equations of line. So here x of t, sorry, v of x, sorry, v suffix x, that is x component of velocity with time on x-axis. You can see the animation, how the velocity changes with time from 0 seconds to 25 seconds. Y component of velocity you can observe here. The animation will show how the y component of velocity changes with time. Now we shall see the animation of r of t, which was in fact under root of x square plus y square, rather x of t square plus y of t square. On x-axis we shall have time, on y-axis we will have r of t, and for 25 seconds we'll have 25 traces. And this animation is playing now for you. This exhibits maximum far off position around this time, some 16-17 seconds. Now acceleration you can find by differentiating velocities, respective velocities. And here you will be able to see the both values are appearing to be constant. So this is how the problem goes. I hope you have enjoyed Maple animation. Thank you for your attention.